All right. Now, this is called use substitute. It's a method that we're going to use that we've already been sort of using. That, let's say you have this. Now, this idea of use substitution comes from the fact that we will be integrating composite functions. This guy's a composite function. In this case, what we want to look for is, you want to look for a higher order function. Three things you want to look for, and actually this should be one. Overall structure of a function in there. That would have been easy to integrate. But the function that we're trying to integrate is messed up. There's a higher order version of it and the derivative of it. Now, here's what I mean by this whole thing. And I'm not expecting anybody to really get this on the first pass, but I want to show this to you to start planting the seeds. And because this is what we're doing. We're just going to be doing integration. We did a little bit yesterday, a little bit today. I'm doing brain confusion. I'm doing a little bit of everything. And then we're just going to start pulling it all together so you guys can just integrate like crazy. Now, in a perfect world, if this was a perfect problem, this would be the absolute value of x squared dx. Because it is the overall structure of what's going on here is there's a little bit out here. This is x, which is a lower order of x squared. But if it was perfect, it would have been just something squared, the integral of something squared. But it isn't, because there's a function here, and then there's a function here. So the structure is this, the integral of something squared, and I'm going to call it u squared, and then I want u prime out front, and then I want du. This is the idea. In a perfect world, we would have had this, but now we have a function here that's being raised to the second power, and we need to take, what would the u prime be? The derivative of the x squared plus 1, which is what rule from derivatives? Chain rule. What would be u? X squared plus 1, wouldn't it? Now what would be du? Two x dx. So it's that idea of implicit differentiation. Now, it's very simple that we're just going to make sure that we have our dx in there. Now, if we looked at our original function and we rewrite it, x squared plus 1 squared times 2 or times x dx. Do I have everything that I need? Do we... This is my u squared, right? Because it would be the original... It would be that composite function squared. And this is going to represent du. What's missing? Yeah, since it's not what it should be, so what's missing? A 2x instead of x, right? Now how do we rectify that situation? Here's what you do. Multiply that by a 2. But can I multiply that by a 2? Or does that change the function? It changes the integrand totally. So how do I undo the multiplying by 2? 2 over 2, or else you can multiply by 1/2 out front. Because that 1/2 and that 2 represents 2 over 2. So now do I have my u squared and my du? Alright, so I have 1/2 times the integral of u squared du, which would be equal to 1/2. What's u squared? What's the integral of u squared? Is it just u cubed over 3? Or 1/3 times u squared? Either way. Tomato, tomato. Plus what? Plus c. So this is now u cubed over 6 plus c. Now, what was my u? There's your answer. Now, like I said, this is going to be the first time that you're dealing with stuff like this. And the idea that there's going to be a function, well, there's going to be an overall, there's going to be a basic function that's being integrated. And in this case, the basic function was just something squared. If you looked at this big thing, it's a bunch of stuff being squared. Alright, that's the big idea of this integral, is a bunch of stuff being squared. So that's what we would want. Now, what we have to do in order to make sure that everything is okay is that when it's a composite like this and not just x squared or x like x squared or whatever, we have to make sure that not only is this function there, but its derivative is in there. And this u substitution is saying, alright, this is going to be, the hardest part is identifying what u is going to be, and then your du. Well, the hardest part is identifying what the u is going to be. And in this case, the u was just this stuff being squared. We're going to do so many examples of this that the u substitution is going to be pretty easy for you, I think. But I wanted to show you that today, just so you start having this. And I want you to start thinking about, all right, now I got all these rules. I got this new method for trying to figure stuff out. We're going to start working on this. And I know we didn't go over what we did yesterday, but we're going to start going over a bunch of examples on how to do derivatives starting tomorrow. I'm going to give you a chance to play around with some of these rules today. But then we're going to go over a lot of stuff tomorrow and start going over more of the procedural. Right now we're in the procedural of how do you take an integral? How do you actually perform integration? Because you need to know how to perform it before you can understand why you're doing it. So